Welcome back. So today we're going to do our second lesson on in our irrational numbers unit. And this one is going to be about approximating irrationals, but also finding them on a number line. So let me go ahead and show you our learning objective so we can get going. So here you'll see that our learning objective says we will approximately locate. Again, approximately means that we're going to get as close as we can to the number or the location on the number line, as opposed to making our best guess. We're going to get as close as possible. Now, our concept is irrational numbers. So today we're going to talk on the concept page about what an irrational number is and what it is not. And then finally, we're going to be approximating these, approximately locating these irrational numbers on a number line. All right, now, in order to make sure we're successful in this lesson, we're going to connect a skill that we already know, approximating irrational numbers, or approximating irrational square roots. And then we're going to connect that to just the idea of an irrational number in general, and then finally approximately locating those on a number line. So let's begin by finding out what is the approximation of the square root of 57 to the nearest tenth. So to begin with, I see that the square root of 57 is right here, or somewhere going to be in between square root of 49 and the square root of 64. So that's where I'm going to begin on my approximation. So square root of 57 is between square root of 49 and the square root of 64. And the reason why we need to know that is because we know the square root of 49 is 7, and we know the square root of 64 is 8. So if we know those two, and square root of 57 has to be between those two, we can then guess our first estimation of the square root of 57 as being 7 point something. I need a decimal between 7 and 8. It can't be greater than 8 because 57 is less than 64. So I'm going to guess 7 point, let's see, 57, it's about right in between 49 and 64. I'm going to make my best guess at 7.6, because I see that it's just slightly closer to square root of 57 is slightly closer to the square root of 64. Well, then I would need to check my guess, my first estimation of this, and I would do 7.6 times 7.6, or 7.6 squared. That will give me 57.76. Okay, well, that is pretty close, but I'm over 57, and that's okay, but we want to always have at least one guess above and one guess below the square root we're trying to approximate. So if 7.6 was above square root of 57, then my next guess should be 7.5. So 7.5 squared, when I multiply those together, I'm going to get 56.25. Now, those are both very close together, so my approximation is really going to be in the middle. But since I only need to go to the 10th place, right, it tells me to go to the 10th place here, I'm going to guess, I'm going to see which one of these two is closer, and I can see that 7.6 gives me 57.76. That is just slightly 1/100th farther away than 7.5 squared, which is 56.25. So my approximation for the square root of 57, right, here's my approximately sign, is approximately equal to 7.5. All right, now at this point, you should now try to do your problem and approximate square root of 27 to the 10th place. I'll give you a moment. All right, welcome back. Well, hopefully you tried it and you found out that the square root of 27 is approximately equal to 5.2. Now, if you need more practice on this, you can go back to our last lesson, or Ms. Yamas is going to go through approximating these over again on this skill in this lesson later on. All right, let's move on to the concept. Okay, so for our concept, we see that irrational numbers, right, this is our concept, irrational numbers, they are numbers, but they're numbers that are what we call non-repeating and non-terminating decimals. Now, non-repeating means that they don't have any sort of pattern in them. And non-terminating, the word terminate means to end, so non-terminating means that they don't end. So irrational numbers are numbers that have no patterns, and yet they also don't ever end. Let's look at an example here. So for my first example, I see the square root of 8 is approximately 2.8. So the square root of 8, this is our irrational number. Now, if it's non-repeating and non-terminating, I see that 2.8 is not quite square root of 8. It's 7.8, right? So 2.8 is not quite right. If I add more decimals to my approximation of the square root of 8, I end up with this 7.99 84656. That is still not actually square root of 8. So here we see that the decimal is now longer. It has not repeated a pattern, and it actually doesn't end. I can show you even more of this number. So if I take the square root of 8 even farther and I square that approximation, it's still not even 8. Now we're getting really, really close, but again, this is just an approximation. This decimal, the square root of 8, will actually never repeat. There is no patterns in this number if we were to keep writing it over and over forever, and it would go on forever. There is no end. It's non-terminating. So that's actually kind of weird if you think about it. This number can't be written down because it's non-repeating and non-terminating. So that actually leads me to the first bullet point, or first attribute here, is that irrational numbers have to be represented with some sort of mathematical symbol or be approximated like we have been learning. So let's look at another irrational number that you might be familiar with, pi. And we have a special symbol for pi. It's actually the Greek letter pi. And the reason why, if you never knew this, why we have a symbol for it is because you can't actually write the number down. It's non-repeating and non-terminating. There's no patterns. It just keeps going. And in fact, I forgot to add the ellipses here showing that it keeps going. So I'll just add that now. Then let's look at one more example of an irrational number, square root of 2. So here we can see that the square root symbol is actually the symbol we use in order to show that the square root of 2 is an irrational number. All right, now let's talk about our non-examples. What are things that might look like an irrational number but really aren't? To start with, the square root of 9. Like I just told you, on the square root of 2 we have a symbol, but square root of 9 is one of these perfect squares where square root of 9 is actually equal to 3. So that is that's not non-terminating. It ends 3. It's not repeating. It's just the number 3. So square root of 9 is not irrational. It's a rational number. Then if we look at the next non-example, 0.333 and that repeating bar above it, well, that repeating bar repeating, that makes it a repeating decimal, unlike irrational numbers, which are non-repeating. There is no repetition. There is no patterns in the numbers. And then finally, the last one, the last non-example, I have 1.4567. Well, that's a decimal, but it terminates, it ends. So that is not an irrational number either. Irrational numbers are numbers that don't have any patterns and they go on forever. And one way that we like to say it is that they cannot be written as a fraction. And they can't be written as a fraction because there's no end to the number. So it doesn't make any sense to think about how would I write it as a fraction if there's no end to it. Now, there's one more thing we need to talk about before we move on, is where and what are we going to do with the irrational numbers in this lesson? We need to be able to approximate them on a number line. We need to be able to find them on there. Now, let's talk real quick about what a number line is. I'm sure you already know and understand, but there's some details here that might help us out later in the lesson. Now, first off, let me get a new highlighter here. A number line is a straight number that has numbers placed at equal distances along the length. This is an important idea, especially later on in this lesson when we're going to be locating these. You'll notice here at the bottom that 1 to 1.25 to 1.5, those are all spaced out by 0.25, and then the next spacing is another 0.25. They're all in equal distance, both graphically and numerically. So a number line allows us to find out approximately, not exactly, but approximately where irrational numbers are on that number line. So here you can see that I have the square root of 2 is before 1.5 because, again, the approximation is 1.4, but it's going to be past 1.25. So in this lesson, we need to understand that irrational numbers are numbers that they're decimals that have no patterns, they do not repeat, and they never end. And therefore, we have to approximate their location on number lines. And that's what Ms. Yamas is going to teach you in the skill development and guided practice section. All right, get ready. Here comes the next step.
Hey everyone, you're now at the skill development guided practice section of this lesson. Step number 1, let's read the problem. let's identify two perfect squares that the square root falls in between. So I have approximate the square root of 31 on the number line. So I know that the square root of 31 is in between two perfect squares, which happens to be, I'm going to actually rewrite it so you guys can see this. It happens to be the square root of 25 and the square root of 36. So right in here. Now, I know that the square root of 25 is 5 and the square root of 36 is 6. Right down the middle, I have 5.5. So I'm going to draw my own number line before I estimate and or place it on the number line. So now I know that the square root of 31 is 6 units away from the square root of 25. The square root of 31 is 5 units away from the square root of 36. So because it's kind of like in the same distance in between square root of 25 and square root of 36, I'm going to start off with 5.5. So I have 5.5 times 5.5 leaves me with 30.25. I'm going to try to see if I can get closer to 31. So I'm going to try 5.6 times 5.6. That leaves me with 31.36. So for this specific approximation, I'm going to say that the square root of 31 is about 5.6. Now, if you want to choose 5.5, it's really close to the square root of 31. I'm okay with that. So now I have to, step number 4, repeat steps number 3 and 4 until approximation is best represented on the square root. We already did that. Now we can place it on the number line, step number 5. So I have in between 5, and notice that it's 4, 5, 6 on the number line. Because I have this word given here, this is going to help me place it on the number line, ladies and gentlemen. That's going to be my tool that I can use to place on the number line. So I have 5 and 6. In between 5 and 6, I have 5.5. That's the halfway mark. In between 5 and 5.6, this is what this little mark represents. So now I'm going to place the square root of 31. And I said it was about 5.6. And I know 5.6 is going to be about right. Oops, excuse me, guys. About right there. I'm going to put my point. So the square root of 31 can be 5.5 or 5.6. Right there. So now I want you to pause the video and try the next one on your own. Approximate the square root of 18 on the number line. Use the skill steps to help you figure it out. Wait time, wait time, wait time. All right, ladies and gentlemen, thank you for coming back to me. I'm going to work through the next problem. Tune in, stay with me, check your work, or if you feel more confident, kind of fast forward to the next set of problems. So I have the square root of 18. The square root of 18 is in between two perfect squares. It's in between the square root of 16 and the square root of 25. So it's in between 4 and 5. And notice that on the number line up here, I have 4 and 5. So I know it has to be somewhere in between those two whole numbers. Right down the middle, I have 4.5. It's like the halfway mark between those two whole numbers. All right, moving forward. Next, I know that 18 square root is only 2 units away from square root of 16, and the square root of 18 is 7 units away from the square root of 25. Because 18 is only 2 units away from the square root of 16, I know it's going to be closer to the whole number of 4. So it has to fall in between this section here, between 4 and 4.5. So now I'm just going to do my guess and check and kind of play with the numbers and see what will give me closest to my approximation. So I'm going to start off with 4.2. 4.2 times 4.2 leaves me with 17.64. I'm going to try to see if I can get closer to the whole number inside the square root sign, which would be 18. So now I'm going to try 4.3 times 4.3. And that leaves me with 18.4. Okay, that's pretty close, ladies and gentlemen. So the approximation of the square root of 18 would be about 4.3 or 4.2. In this case, I'm going to go ahead and say it's about 4.3. I'm going to graph it. It has to be in this section here. Remember, in between 4 and 4.5. 4.3 is like towards the middle, so I'm going to put my point there. And I'm going to say that the square root of 18 would be in this section here. Okay, moving on to a few other problems. Stay with me. You guys are doing great. So I have the square root of 60. Approximate the square root of 60 on the number line. Notice that in this number line, I have more increments in between. I have 7 to 8. The halfway mark is here. Would be 7.5. Now it's broken up into quarter sections. So I'm just going to write that here. So I have 7.25. Then I have 7.75. And how do I know that it's broken up into quarter section? Because there's 3 sections evenly split to get to one whole number to the next. So I have the square root of 60. The square root of 60 is in between 2 perfect squares. It's in between the square root of 49 and the square root of 64. So that leaves me with 7 and 8 as a whole number. So I know that the square root of 60 has to be in between these 2 whole numbers, 7 and 8. Will not be in between 8 and 9 because that goes over the square root of 16 in the amount of equivalence. So now I know that the square root of 60 is 11 units away from the square root of 49, and the square root of 60 is 4 units away from the square root of 64. Because 60 is closer to the square root of 64, I know it has to fall somewhere in between 7.5 and the whole number of 8. So now I'm going to do my guess and check strategy. I'm going to start off with 7.7. Now, ladies and gentlemen, I'm just going based on my approximation. You can start off with 7.5, 7.6, 7.7, 7.8, 7.9 in order for you to get closest to the approximation of the square root of 60. So I'm going to start off with 7.7. 7.7 times 7.7 leaves me with 59.29. Okay, that's close to the whole number 60. I'm going to try to see if I can get even closer. I'm going to try 7.8. 7.8 times 7.8 leaves me with 60.84. So in this particular problem, I can say, and notice that it's really close, ladies and gentlemen. If you want to round up, you can. Now, for this case, because it's close, this one kind of goes over by a lot. And this one's not going over. I'm going to say the approximation is about 7.7. So now I need to graph 7.7. Now notice, ladies and gentlemen, I rounded up and I do actually have a 7.75 here. It's close. It's on that mark. So I'm going to place my point there and I'm going to say the square root of 60, draw my arrow, is about 7.75. Pause the video. Now I want you to try the next one on your own. Approximate the square root of 77 on the number line. All right, thanks for coming back to me, ladies and gentlemen. We're going to go ahead and get started with the square root of 77 and approximate it on the on the line using the square root as my perfect square. So I have the square root of 77. It's in between two perfect squares. Happens to be in between the square root of 64 and the square root of 81. 77 is 13 units away from 64, and it's 4 units away from 81. Got it. So now I know it has to be in between the whole number 8 and 9. Right down the middle, I have 8.5. So because the square root of 77 is closer to the square root of 81, I know that it has to fall in between 8.5 and 9. Again, I'm going to do my guess and check. And I'm going to say, start off with 8.7 times 8.7. Leaves me with 75.6. I'm going to see if I can get even closer. And I'm going to try 8.8 times 8.8. And that leaves me with 77.4. Now I want to get to 77. So the closest that I am going to say, it's going to be the approximation of 77 is about 8.8 without going over completely over. So now I have 8 and 9 on the number line. That is my focus area on this number line section. Sorry guys, it keeps kicking me off. Right down the middle, I have 8.5. These are based on quarters, so I'm going to say 8.25. Then I have 8.75. So next, I'm going to place square root of 77, which is about 8.8. It's going to be somewhere in between here, guys, between 8.75 and 9. I'm going to put it right in the middle of that section. And I'm going to label it as the square root of 77 is about 8.8. And I graphed it on the number line.